Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic standard distribution, we are going to see what is normal distribution and its case study in this lecture video. So, welcomes to the normal distribution is one of the most important continuous probability distributions. So, many naturally occurring data sets follows this normal distribution. For example, students' marks, measurement errors, physical characteristics are all the normal distributions. So here is the bell-shaped curve in which the expectations are met and below expectations, serious underperformance and above expectation and excellent performance are calculated. So in between it is 50 to 50 percentage. So in the negative curve it will be we need performance like that. In the positive side, it is all good, excellent performance level. So here is the DT with normal distribution. So unknown battery life and defining problem, applying normal distribution, calculating the probability and the known battery life. So this is the 5 stages. A normal distribution is represented by a bell-shaped curve and it is symmetric about the mean. Mean, median and mode are equal for this distribution. Next, the total area under the curve represents probability and f of x for this distribution is 1 by sigma into root of 2 pi e power minus x minus mu the whole square by 2 sigma square, whereas mu represents the mean and sigma is standard deviation. So let us see an example of a normal distribution. So for a normal distribution data set, most values are concerned or connected, concentrated around the mean. So the very high or very low values occur less frequently. So this property makes normal distribution suitable for analyzing real world data. So let us consider the case study where a student's performance analysis using normal distribution is calculated. So an institution wants to analyze the semester marks of students and understands the overall performance pattern. So first step is to calculate the number of students or to collect the data. The mark of students are first collected from examinations. So the collected mark shows the variation among students. Obviously it will show. So next we are going to perform the statistical analysis for that. So using normal distribution, mean indicates average student performance and the variation, that is standard deviation, indicates the variation in marks. So the bell-shaped curve helps classifying students into performance levels, different performance levels. So the outcome will be the faculty members can identify students requiring additional support, understand overall academic performance of a students, next plan improvement strategies. So here are the examples of normal distribution. So to find the height of people, rolling a die, tossing a coin, shoe size, blood pressure and IQ are also an normal distribution problems. So here is one example in which the average price of product is 5 and 5 and the standard deviation is 52. What is the probability that? So here the price would be 512 and the price would be greater than 518 are the solutions, and here are the bell-shaped curves. So understanding normal distribution, first mean is identified, standard deviation 68% rule, that is approximately 68% of data falls within one standard deviation pattern. Next is 95% rule, around 95% of data falls within two standard deviations. Next is statistical inference, so crucial for statistical test and methods. Next is real world phenomenon. So here is the mind map in which first we have discussed about the bell-shaped curve and axis. Next mean, median, mode are discussed. Next the real life case study is discussed, and here is the assessment questions. So in a perfectly symmetrical normal distribution, what is the relationship between the mean, median and mode? So as we have discussed already, mean, median and mode are all equal for the normal distribution. So, which of the following statements is a direct consequence of the symmetry of the normal distribution? So, first is the curve never touches the horizontal axis. It's not true. Next, the probability of observing a value at a certain distance above the mean is equal to the probability of observing the value at the same distance below the mean. Next, approximately 95% of the data falls with 2 standard deviation of the mean. Next, the total area under the curve is equal to 1. So, we know that the option D is correct, option C is correct. Here are the reference for this video. So, as concluding, normal distribution represents continuous data. It follows bell-shaped curve. Mean and standard deviation define the distribution, and it has applications in education, engineering, and data analysis. So, thank you.